Welcome to Future Legacy.
Smartwatches, unlike most other computing devices, are unique in that they reside on the body. This has the great potential to allow a user's arms and hands to be transformed into an expressive input and sensing platform. Today, all smartwatches contain accelerometers, but APIs generally limit the sample rate to around 100 Hz. Using a custom kernel we developed, it is possible to put a smartwatch's accelerometer into a rarely used high-speed mode, 4,000 samples per second. We unlock a wide variety of applications by using this high-fidelity data to capture and process bioacoustic signals, small compressive waves that propagate through the user's arm. Here we plot three sensors side by side. At the top of the laptop screen is conventional 100 Hz accelerometer data. When holding an object, such as this electric toothbrush, we can see coarse movement, but little spectral information. In contrast, our 4,000 Hz signal, shown in the middle of the screen, easily captures the sinusoidal oscillations of the toothbrush's motor. Finally, at the bottom of the laptop screen, we plot the microphone's data. Recognition is often challenging due to background noise, whereas our bioacoustic 4 kHz channel only sees the signal when the toothbrush is grasped. We explored how our approach could enable interactions in 3 application areas. Of note, all of the demos shown in this video were powered by real-time classification of bioacoustic signals. First, our technique can be used to classify hand gestures, such as flicks, claps, scratches, and taps. Here you can see a user tapping on the skin, which creates distinctive micro-vibrations that propagate through the arm. We can also capture and classify one-handed gestures and two-handed gestures. By combining these actions with motion tracking, we can enable a variety of input modalities, such as buttons, sliders, radial knobs, counters, hierarchical navigation, and positional tracking. We created several example applications that utilize these input modalities. In the smartwatch launcher, we can place navigation controls on the skin. Users can traverse back up through the hierarchy with a flick gesture. Gestures can also be used to control external devices. Here, a user snaps his fingers to turn on the nearest light. A pinching gesture is used as a clutch for continuous brightness adjustment. A flick confirms this manipulation. In this example, the user claps to turn on the TV. Wave gestures navigate and snaps select. Our sensing approach can also be used to identify grasped objects. When a user operates a mechanical or motor-powered device, the object produces characteristic vibrations which transfer into the operator. Our bioacoustic sensing smartwatch can capture and classify these signals, affording interactive applications the ability to better understand their context of use and further augment everyday activities. We can augment the kitchen experience by sensing equipment used in preparation of a meal. This step requires the ingredients to be mixed, but not over-agitated, and so a progress bar is shown. Our technique can also sense unpowered objects, such as this guitar. In this app, we detect the closest note and provide visual feedback to tune the instrument precisely. We can augment analog experiences with digital interactivity. For example, with this Nerf gun, we can detect the loading of a new ammo clip and then keep count of the number of darts remaining. Of course, many objects do not emit characteristic vibrations, which means we cannot detect them. However, we can instrument them with an acoustic tag that emits inaudible structured vibrations that carry data. This room placard has been instrumented with an acoustic tag. The user can touch the sign, which transmit the person's contact details to the smartwatch. Finally, we also instrumented a glue gun with an acoustic tag. It broadcasts an object ID that enables the smartwatch to know what object is being held. It also transmits metadata, in this case, the ideal temperature for operation, along with the current temperature.